Hi, I'm Karen Savage, and I'd like to welcome you to a video series on flood resiliency in British Columbia. I would like to start by acknowledging that this video is being filmed on the traditional and unceded territories of the Musqueam, Squamish, and Tsleil-Waututh peoples. Along with my colleague Diane Meehan, I am co-author of BC Housing's Builder Guide to Site and Foundation Drainage. We have worked with BC Housing and a multidisciplinary team in order to compile and develop flood resiliency recommendations to inform the building industry in British Columbia. These recommendations can be found at the link provided in the video description. We are pleased to present this video series educating British Columbians on flood risk mitigation measures. This series of recordings is part of BC Housing's Mobilizing Building Adaptation and Resilience Initiative, or MBAR. MBAR promotes designing for resiliency of buildings against natural disasters such as flooding, earthquakes, and wildfire. This video series will offer solutions for various types of developments at risk of flooding, including single-family residences, multi-family strata developments, and commercial developments. This video presents an introduction to the video series, and both new building construction and upgrading of existing buildings will be discussed. We have identified 5 key risk factors for types of sites which may be vulnerable to flooding based on their location. These include sites which are located near water bodies and sites at the toes of slopes. Additionally, widespread flat areas can commonly represent a potential floodplain, and developments there may be at risk of overland flooding. Finally, sites with a high groundwater table or sites that have stormwater discharge locations which are vulnerable to backing up may have enhanced ground surface and below-grade flood risk. However, it is important to note that flooding is not necessarily limited to specific geographical regions. There are many existing reference codes and best practice guidelines which inform building design in BC, including in areas of flood risk. We encourage you to review these guidelines and others that are linked in the video description. As an introduction to the importance of designing for flood resiliency, we are going to look at 3 case studies pertinent to business planning, community planning, and building design. For most British Columbians, our real estate holdings are our biggest asset. Understanding and managing flood risk is important for protecting this asset. You can learn more about the flood risk of individual properties by consulting the resources at the links provided in the video description. Additionally, your local municipalities or regional districts, as well as civil, hydrotechnical, geotechnical, or environmental engineers may be able to advise on these issues. Note that flood mapping and reports older than about 10 years might be out of date and should be considered with caution. If your home is in an area at risk of flooding, there are steps that you can take to ready yourself and protect your property. Acquiring appropriate insurance coverage is a key protective measure. Make sure that you read policy exclusions carefully and seek additional coverage if warranted. Note that coverage against water damage may not include flooding, depending on the source. Also note that certain types of flood insurance are not available for all locations. Other measures which can assist in physically protecting your home, facilitating cleanup after a flood event, and building back better can be found at the links provided in the video description. When in the initial design and planning stages of a new building or development, it is important to consider costs over the entire building life cycle and not just the costs of construction. While a conservative design, or a design that has included greater resiliency and protective measures, may initially be more expensive to build, future cost savings must be considered and may offset this initial expenditure. For example, if a flood event occurs, the costs associated with cleanup, in addition to redesign, permitting, and future construction, and the loss of use of the building, including rental income, may be significant for an originally non-conservative or non-resilient building design. Additionally, insurance and maintenance costs would be expected to be more for a non-resilient design versus a resilient design. Finally, although difficult to quantify in monetary terms, it should be appreciated that conservative design leads to improved safety, stability, and security for building users. For property owners with multiple holdings, a post-disaster recovery strategy could be aided by preemptively securing a line of credit against a mortgage-free property in an area of relatively low flood, wildfire, and seismic risk. Design philosophy statements and maintenance records can both be useful tools in proactive asset development and management. In our experience, it can be challenging to carry out a review of an existing building after it has been constructed. Drawings can go missing or do not match the actual constructed condition. Additionally, building codes, flood regulations, and other standards frequently change, and it can be difficult to ascertain the goals or intents of the original design team decades into the future. To help bridge this gap, we are proposing that a design philosophy statement be completed for new buildings. This document would provide the vital statistics for a development and would document key information including applicable codes, flood construction levels, and other factors governing the design. Key design decisions made by the owner and project team, including allowances for future building upgrades, could also be recorded. If this statement is put on title, it will be readily available to future owners and design teams who may be involved with building repairs and upgrades. Maintenance manuals are also important documents as they provide a record of the current status of the building and its components, if kept up to date. Links to templates for design philosophy statements and maintenance manuals are readily available in the video description. The next case study that we will now share relates to community planning and considerations in the face of climate change. Devastating wildfires are becoming increasingly common in British Columbia. These wildfires can have the effect of making soil hydrophobic. This means that the soil, in a sense, repels water, and it has reduced rainwater infiltration, resulting in increased surface runoff. The loss of vegetation due to wildfire also results in increased rainwater runoff as leaves and roots no longer take up water by transpiration and osmosis. This increased runoff and loss of root mass cohesion can also increase erosion and the risk of slope instability. In 2021, the White Rock Lake fire devastated Monty Lake in BC's Thompson-Nicola Regional District. The next time Monty Lake hit our headlines was in late spring 2022 when mudslides inundated parts of the community, including the adjacent Highway 97. Even as a small community coped with cleanup from one disaster, they had to refocus and muster resources to address the subsequent related disaster. In the face of climate change, improving resiliency on a community level is a complex issue that does not have a single solution, but this is becoming increasingly important for all of us to consider. Our next case study pertains to the design of underground parkades. If underground parkades are located in an area at risk of overland flooding, a flash flood may occur in the parkade if the floodwaters overtop the parkade ramp or another opening. This flash flooding can occur very quickly and can pose a serious risk to human life, especially as people may be inclined to go into a flooding parkade to move a parked vehicle before it is damaged. Parkade overtopping may occur at the parkade vehicle ramp, at exterior access stairwells, into parkade air vent shafts, via ports or drains through the podium slab, or in other areas. Pressure against doors due to only a few feet of water can make them impossible to open. This flooding can trap and drown people within the parkade. Our multidisciplinary team has developed and designed a vent shaft which can be used as an emergency egress via which people trapped in a parkade can escape rising floodwaters. A link to a fully detailed vent shaft design drawing, complete with construction specifications, can be found in the video description. After the 2013 Calgary floods, the sight of hoses winding up parkade ramps to pump out flooded parkades was common. To aid post-flood recovery, our vent shaft detail also includes a deep sump. Pumps can be directly lowered into this sump to facilitate dewatering, thereby increasing the efficient removal of floodwaters from underground parkades. Thank you for listening. I wish to express our thanks to our team of experts. We hope that this video has offered you new insights related to flood risks and planning for flood-resilient communities and homes, and that you will join us in future videos.